All right, we want to find the sine inverse of 3 over 2. All right, so we have the composite of a function with its inverse. Okay, so of course, the main property of that is if you take a function, right, and we compose it with its inverse, well, we should actually just get that argument, right, whatever's inside. So similarly, f inverse of f of x should just equal whatever that argument is, right? So at first glance, you look at this and say, oh, I have a function. It's composed with its inverse. So my answer here should be 3 over 2. Okay? And actually, you can't really do that in this case. We have to verify a couple things first. And the reason is because we are dealing with inverse trig functions. So what do I mean by that? Okay? We know that if sine inverse of y is equal to x. Now I'm just using x and y here, right? It's not the same x here. Okay, but we know that x is the angle, right? We know that for sine inverse, the angle has to be between pi over 2 and negative pi over 2. Okay? But also, the length, right, this y value, the number that goes in here, has to be between 1 and negative 1. Okay? So when we look at this, wait a minute, 3 over 2, that's 1.5, right? So this number is bigger than a half. Well, if you think about it, right? If you think about it, this is pretty much asking the question, right? If sine inverse of 3 over 2, that's equal to some angle. So where does sine equal 3 over 2, right? Where does sine equal 1.5? And actually that doesn't exist, okay? So that means that, well, sine inverse of 3 halves does not exist. So of course, then the sine composed with the sine inverse of 3 halves, that does not exist either. Okay, so this answer does not exist. This does not equal just whatever this is, right? So you always have to check the domain and range of your inverse trig functions.